Continuing with polynomial functions, now we're going to talk about within polynomials what are turning points and what is end behavior. I know the writing is a little small here, but I will explain it in detail. So if I just have some function, some like crazy looking function here, anytime the graph turns around, what I mean by that is this graph starts off increasing, meaning it's on its way up, and then it gets to here and it turns around. It actually does like a little flip and starts going downwards. We call that a turning point because that is a place where the graph was going on its way up and then started going down. Same thing right here. If I were to look down here at this bottom peak, we have another turning point because now the graph starts to go up again. If you think of it like you're riding a roller coaster, every time you get to the peak of a hill or the valley of like the low spot of the hill, those are called turning points because that's when your roller coaster switches from going up to going down or from going down to going up. End behavior is exactly what it sounds like. What is happening to the graph at the end? So here's the right end, here's the left end. So we're going to look at functions and be able to figure out from a picture or from an equation, what is the end behavior? What is happening? Is it heading upwards or is it heading downwards? And all polynomials will be doing one of those two things. So I put on here to take out your calculators, but I think I can do this without. If you look at a linear function, linear functions are either going to have positive slope, meaning it's on its way up the whole time, or a negative slope, meaning it's on its way down the whole time. When I look at end behavior, the left end, so if we talk about end behavior, the left end, I'm going to write this down here, is when x goes to negative infinity because that's going to the far left. The right end behavior is going to be when x goes to positive infinity because that's the far right. So if you think of a number line, you have a negative infinity and you have a positive infinity. There could be different end behavior on each end. It might be doing something different on the left as it's doing on the right. If it is going up on an end, we would say that the function is going towards positive infinity because that means the function is headed upwards. If it is going down, we would say that the function is headed to negative infinity because it's headed downwards. So with a line, if you look at this line on the first one, the left side is going downwards. It's going towards negative infinity. The right side is going upwards towards positive infinity. This line is doing the opposite. On the left side, it's heading up. On the right side, it's heading down. Quadratics have identical end behavior on each side. If you think about your quadratics, your parabolas, they're either right side up and they look like a U, or they're upside down and they look like upside down U. For the one that's right side up, both ends would be going upwards to positive infinity. For the one that's going down, both ends would be going downward to negative infinity. So we would say a quadratic has an identical end behavior on both sides. If it's a cubic, so your cubic functions, a positive cubic, meaning there is no negative in front of it, looks like that. And your negative cubic looks like this. For your positive one, as you go to the left, it's going downward. So we would say the function is headed to negative infinity. And as you go to the right, your function is going up towards infinity. But the negative one flip-flops. This time, as you go to the left, it's actually going upwards. And as you go to the right, it's actually going downwards. So again, upwards like this, downwards like this. X to the fourth is going to look just like your parabolas. If it's positive on the ends, it's going to go like this. Negative, it's going to go like this. The only thing that will be different is the stuff in the middle. If something is a fourth degree, it could have more turning points. It could have more kind of mess in the middle, but your end behavior is going to be just like a parabola. For this one, for a positive one, as we go to the left and to the right, both sides have my function going up towards positive infinity. With the negative one, as I go to the left and to the right, both sides are going down to negative infinity. And then you're going to continue to see this pattern. Your x to the fifth looks a lot like your x to the third. Your negative x to the fifth looks like your negative x to the third, where your end behavior is going to be whatever happened up here. Your x to the sixth is going to look a lot like x to the fourth and x squared, where your end behavior is going to be the same on both sides. If it's positive x to the 6, it's going to be going up in both sides. If it's negative, it's going to go down. So here's the pattern if you haven't figured it out yet. It depends on if the degree is even versus odd. If we have an even degree versus an odd degree, we have a better idea of what the end behavior looks like. We can also know if something's even or odd, get an idea of what it would look like, or if I give you a picture, you could tell if it's even or odd just by looking at the ends of it. So here's how we summarize this, looking at even versus odd. If it is even and you have a negative leading term, so it's like a negative x to the second or negative x to the fourth, as x goes to infinity and as x goes to negative infinity, your function will go downwards to negative infinity. It will head down. If n is even and your first number is positive, like an x squared or an x to the fourth, both sides, so the left and the right, will go up towards positive infinity. So we would say both ends are upward towards positive infinity. If it is odd, it depends on if it's positive or negative. The ends will do the opposite. So odd and negative looks like this. Odd and positive looks like this. So if it is odd and negative, as I go to the left, my function will go up to positive infinity. And as I go to the right, my function will go down to negative infinity. If it is odd and positive, as I go to the left, my function goes down to negative infinity. And as I go to the right, my function goes up to positive infinity. And the nice thing with these is you will have some that are completely visual that you can look at the picture and see on the left side of my graph. If you're typing in the calculator, on the left side of my screen, is it going up or down? On the right side of my screen, is it going up or down? You also will have ones that are written as an equation. And if you're struggling to remember what it does, you can always graph it on your calculator. You can always graph it on Desmos and see what is going on. I guess the biggest thing to kind of recap, when it's talking about the left end behavior, it's talking about what happens to negative infinity. When it talks about your right end behavior, it's talking about the x's as they go to positive infinity. If you're trying to describe something as going up on the ends, you're saying that the function is going towards positive infinity. And if you're trying to describe that something goes down on the end, then your function is going to negative infinity. That's kind of an overall recap of how to do end behavior.